In the final weeks of August 1944, German observers stationed along the French coast began noticing something deeply unsettling. Reports arriving at the headquarters of Flak Regiment 155 revealed interception figures that made no mathematical sense. The V-1 flying bombs, Hitler's so-called vengeance weapons, were being destroyed in the sky at a rate that defied everything their scientists had ever calculated. Through their binoculars, stunned officers watched the bizarre spectacle unfold. The pilotless missiles, launched toward London before dawn, were detonating in mid-air, not by fighters chasing them down, nor by barrage balloons, but by anti-aircraft shells that seemed to burst at precisely the right distance every single time. It was as if the British gunners possessed a supernatural aim. Colonel Max Wachtel, the man overseeing the entire V-1 offensive, could hardly believe the numbers he was reading. In June, only a fraction of the flying bombs had been shot down. By late August, more than 3/4 were being destroyed before crossing the Channel. And on one extraordinary day, the figure reached 82%. Something impossible was happening, and it terrified him. What Wachtel and his fellow officers could not know was that they were witnessing the debut of one of the Allies' most closely guarded wartime secrets. The weapon responsible for this sudden miracle of accuracy was protected under a classification equal to that of the atomic bomb itself. It was known simply as the VT fuse, short for variable time. In reality, it was the world's first proximity fuse, a small electronic brain that allowed an artillery shell to detonate automatically when it came close to a target, rather than requiring a direct hit. The origins of this secret stretched back to early June 1944, just a week after D-Day. Hitler, furious over the Allied landings in Normandy, ordered the immediate use of his long-promised vengeance weapons against London. On June 13th, the first V-1 crashed into the city's East End, destroying homes and a railway bridge. 6 people were killed and many more wounded. For the German command, it was only the beginning of what they believed would be a campaign of terror capable of breaking Britain's morale. The V-1 was a product of years of experimentation, a pilotless aircraft powered by an Argus pulse jet engine and carrying almost a ton of explosives. It could reach speeds over 400 miles per hour, faster than many fighter planes. Major General Walter Dornberger, the head of Germany's rocket program, estimated that even a modest success rate would inflict more destruction on London than the entire Blitzkrieg had ever achieved. Each missile was cheap to produce, required no pilot, and could be built in large quantities by forced labor. At Peenemünde, the center of German missile research, optimism was high. The engineers behind the project were confident that the Allies had no defense capable of stopping the new weapon. Dr. Robert Lusser, who designed the missile's control system, had even calculated the odds. Hitting a V-1 with anti-aircraft fire, he claimed, was less than 1 in 10,000. The missile's small size, unpredictable altitude, and incredible speed made it almost untouchable. But within a few short weeks, reports began to show something unexpected. The British defenses, far from collapsing, were improving at an alarming rate. In late June, interception climbed to 24%.
By mid-July, the success rate was inexplicable. German technicians recorded cases where British gunners claimed kills with a fraction of the ammunition that should have been needed. Witnesses saw V-1s flying steadily toward England, suddenly surrounded by flak bursts and then tumbling from the sky, even though the explosions seemed too far away to have hit them directly. What they were unknowingly observing was the effect of proximity fuses, tiny radio transmitters hidden inside each shell. These devices could sense when they were near a target and trigger detonation automatically. The Allies had secretly developed and tested the technology in the Pacific more than a year earlier. By the summer of 1944, American factories were producing them in staggering quantities. German intelligence had in fact heard whispers about such research. As early as 1939, a document known as the Oslo Report had mentioned proximity fuses, but German scientists dismissed it as British disinformation. They had tried to build something similar themselves, experimenting with dozens of designs, but none survived the enormous forces generated when a shell was fired. Their conclusion was that such a device was simply impossible. By August 1944, American production lines were turning out 40,000 of these fuses every single day. The British had reorganized their entire coastal defense system to make full use of them. Using American radar and automatic gun tracking systems, they created a gun belt along the southern coast, ensuring that any unexploded shells would fall harmlessly into the sea and not into enemy hands. When a V-1 crossed the English shoreline, radar automatically locked onto it and calculated its trajectory. The guns fired shells fitted with the new fuses. Each contained a miniature radio transmitter built with components from companies like Sylvania Electric and Western Electric. When the radio signal reflected off the nearby missile, the fuse's internal circuit triggered an instant detonation, shredding the target with steel fragments. On the peak day of the campaign, 82% of all incoming V-1s were destroyed. The German High Command panicked. Emergency inspections found nothing wrong with the missiles themselves. The fault lay somewhere beyond their understanding. Despite all their efforts, altering launch patterns, increasing altitudes, firing in salvos, even using bad weather, the result never changed. The Germans ran into a wall they couldn't see. The Allies had achieved what their scientists considered fantasy. The secret was so tightly guarded that even Allied troops didn't know what made their new shells so effective. Every proximity-fused round was counted and recovered when possible. Naval patrols scoured the channel to prevent the Germans from retrieving unexploded shells. While Germany struggled to build its rockets using slave labor in underground factories, America was employing tens of thousands of volunteer workers, many of them women, to mass-produce advanced electronics on an industrial scale. By the end of the war, more than 20 million proximity fuses had been built at a total cost exceeding $1 billion wartime dollars. By September 1944, the V-1 offensive was effectively broken. Of the thousands launched toward Britain, only a small fraction ever reached London. The casualties, though tragic, were far below what the Germans had hoped to inflict. Without the proximity fuse, the death toll likely would have been 4 or 5 times greater. The Germans tried to regain the initiative by launching their next weapon, the V-2 rocket, which traveled too fast for interception. but it came too late to change the course of the war. The V-1 campaign had consumed enormous resources and achieved little. In hindsight, it became one of the greatest technological defeats in military history. When Germany finally surrendered in 1945, their scientists were shown captured examples of the Allied fuse. They were stunned. They believed such technology to be physically impossible. Vacuum tubes that could survive the violence of a gun's firing. Tiny batteries that remained dormant for years yet activated instantly. Circuits that could think for themselves. One German physicist estimated they were at least a decade behind the Americans in electronics. Dr. Merle Tuve, who led the Proximity Fuse project at Johns Hopkins University, later reflected that the secret of success that totalitarian regimes could never replicate. The proximity fuse became one of the war's silent heroes. It made anti-aircraft guns 5 to 10 times more effective and saved countless ships and cities. U.S. Navy Secretary James Forrestal later declared that without this ingenious device, the push across the Pacific could never have advanced so quickly or with so few losses. While Germany relied on slave laborers dying in underground tunnels to build its weapons, America's factories were filled with volunteers working overtime for extra pay, unaware of what exactly they were creating, yet proud to contribute. Many only learned after the war that their effort had saved London from destruction. The secrecy surrounding the project was absolute. Even when ground troops could have used proximity fuses to devastating effect, their deployment was delayed for fear the enemy might recover one. Thousands of Allied soldiers died because the secret had to be protected. In the end, the V-1 program stood as a symbol of wasted ambition. Germany had poured immense resources into weapons that achieved little, while the Allies invested in technologies that multiplied the effectiveness of existing arms. The contrast was stark. Germany handcrafted wonder weapons, while America mass-produced efficient ones by the millions. The proximity fuse marked a turning point in the history of warfare. It proved that victory in the modern age would depend not only on bravery or tactics, but on scientific collaboration and industrial capacity. The day Britain's coastal guns destroyed 82% of the incoming V-1s, the nature of war itself changed. The Germans never realized what invisible hand had destroyed their vengeance weapons. They had done everything right according to their own science, yet were defeated by technology their ideology had made them incapable of imagining. The proximity fuse turned Hitler's terror weapon into London's salvation. It was the triumph of open collaboration over secrecy, of industry over ideology. And on that quiet August morning of 1944, as burning V-1s fell from the sky into the Channel, the future of warfare had already been decided by a tiny electronic brain no bigger than a fist.